Hello. I want to go over this reshape matrix reshape matrix problem in LeetCode. It involves taking a m by n sized matrix and inputting a new amount of rows and columns and reshaping um, the matrix. So I'll show y'all how to do that here. Um, so my way of thinking is first off, we need to get the rows of our current matrix, dot size, and then int columns is equal to mat at array 0, matrix at array 0 dot size. And then now in order for us to be able to reshape a matrix, um, the rows times the columns must be equal to the rows times the columns of the original matrix. Because that means they'll have the same amount of elements. And if not, well, in this problem, we're just going to return the original matrix. Um, so here we're going to say int elements elements in matrix is equal to r times c, the rows and columns that we're passing, and then we're going to have an if statement if uh elements in matrix does not equal rows of the current matrix times the columns of the current matrix. We're just going to return the matrix, the original matrix, return mat. Um, and if we can switch, so if R times C rows times columns of the new reshaped matrix is equal to um, the elements within matrix, uh, what we want to do is first off, we want to pass the because remember this is in a 2D matrix. We want to pass those elements to be into a 1D vector, and I'm gonna show you guys why in just a bit. So here we're going to declare a vector of integers called flattened flat en matrix. And then we're going to use nested for each loop. So for constant const auto. So auto is just like automatically detecting what kind of data type we're going to use, and it's going to be of type vector. Const auto row within the matrix, so mat. And then, so this is going to grab the current row of the 2D matrix. And then for const, or we don't need const for int element within the current row. So this is going to grab the current number within the current row that we're in. We're going to say flattened matrix dot pushback the current element. So essentially this is just grabbing the um the numbers within the vectors, the big vector and then the mini vectors within, and just doing this within the flattened matrix, just passing it into like a regular array. Um so after this we want to then pass we want to create a new matrix, a new double vector matrix. So we're going to grab this and call it new matrix. And this new matrix is going to be of size our new rows, so whatever new rows we want, and then a vector, std vector, int, integers of amount columns. So amount C. So essentially this is saying we're going to have our many rows, and within each row, we're going to have C amount of elements within each row. So if we had say 3 rows, we'd say 1, 2, 3 rows, right? and say columns we pass in five. For each row, we're going to have a vector of five numbers. So I'm just going to say one, two, three, four, five. So row one here would have five elements, and then row two here would have another five elements, and so on and so forth for row three as well. So that's essentially what this line means. Um, and I'm gonna draw that out later so you guys can understand it better. And then next we want to have a uh, an index or like a counter for flattened matrix. So we can iterate through flattened matrix as after it's been initialized. So we're just gonna call that flat matrix. Sorry, int flat matrix index. We're gonna set that to 0. And then we're going to cycle through. We're gonna have two for loops cycling through into the rows and columns, and then passing those into the new matrix. So we're gonna say for int row is equal to 0, while row is less than the row that we passed, plus the row, and then for int column is equal to 0, um, while column is less than C, which is the columns we passed in, plus column. And then here, what we're gonna do is we're gonna say new matrix at array row column is equal to flattened matrix at the current flattened matrix index. And then we're gonna say flat matrix index plus plus. So this is going to grab so if you have one, two, three, four, remember this is technically 0, 1, 2, and 3. Since we're doing 0 index, it's going to grab the 0 index, so it's going to grab 1 and pass it into the new matrix. But why is new matrix not working? New matrix is undefined. Oh, it's because of this. I'm tripping. Sorry. So yeah, that's essentially what it's going to do. Uh-oh. And then after that, we're going to return the new matrix. Um, so yeah, so let's see it in here. Let's call solution. Just make the small one. And then we're going to have int, let's copy this, sorry. Copy this. Why is it not copying? There we go. Call this matrix. It's equal to, let's say, 1, 2, 3. So that's our first row. 4, 5, 6. That's our second row. 7, 8, 9. Oh, I forgot the brackets. That's our third row, right? So here we have a 3 by 3 matrix. Um, and let's say for our new, let's just make a error. C error. Let's say R times C. I'm just gonna make it short. Does not equal elements in matrix. Just a little message to print out in case the rows and columns don't match. So here we're going to say int r is equal to, so we can convert it this into whatever multiplies into 9. So let's just say we have one row and then int column or int c is equal to, which is column 9. So 1 times 9 is 9. So we're just going to have one row with 9 elements in it. and that's going to be our new matrix. So we're going to say, let's create another vector matrix down below. And let's call this new matrix is equal to solution dot matrix reshape, and then pass in the original matrix. And then if we then to print it out, we're going to do, sorry. And then we got to add rows and columns. There we go. And then here we're going to say int row is equal to 0. Well, row is less than, and we need to get the new matrix size of rows. So int, I'm going to say n rows for new rows, or actually new rows is equal to matrix dot size int columns is equal to matrix. Sorry. New matrix. I need to change the top one. New matrix at array 0 dot size. Here we're going to say new matrix. There we go. So we're going to say new rows. What's left in new rows plus plus row. And then for int column is equal to 0, while column is less than new columns. Sorry, this new columns plus plus column std cout new matrix at array row and array column. Print this out with a space between the elements within the rows, and then std cout std and l for a new line. Why is this not working? Where am I missing? Oh, here, sorry. Here we go. So here, this should be a 1 by 9 matrix. Terminal. Yep, there we go. 1 by 9 matrix. Let's say we added 3 more elements, 9, 10, 11, 12. So any multiples to get to 12. So if we do 2 by 6, or 6 by 2 in this case, so 6 rows, 2 columns. There we go. See, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. It should be 12. I put 13. And okay, so let's say we put 7, and it's gonna show us a bunch of random numbers because, um, oh no, okay, never mind. It returned the original matrix, so it returned um like this. So because this is our original matrix, it returned it looking like this. There we go. You see, R times C does not equal elements in matrix. We just return the original matrix, and boom, here it is. You see. So yep, this works. So and I could put it in the delete code for y'all to see. Run. And there we go. Both cases work. And I submit it and it works. So I'll show you guys step by step on my iPad right now. Okay, I'm going to be going over the code that I just did for the reshape matrix. So for our main function, we have a vector of vectors type int. And this is going to be called matrix. So we have the big brackets. 1, 2, 3. So blue is the big matrix, or big vector, sorry. And then the red ones are the mini vectors within that big vector. So for, shoot. 4, 5, 6. 7, 8, 9. 10, 11, 12. Okay, so we have the big vector with the mini vectors within. So first off, we're going to get the int rows, which is equal to matrix, matrix dot size. So this is going to grab the size of however many vectors are within the big vector. So here we have 1, 2, 3, 4. So our rows would be 4 in this case. So this equals 4. And then columns is equal to matrix at array 0 dot size, which then goes to, since these are technically 0 indexed, 0, 1, 2, 3, we come here to the 0th index and we count the size of the elements within, which is 3. So our columns are going to be 3. So this is a 4 by 3 matrix. And then we want to declare int elements in matrix. So elements in matrix is equal to, and remember that we passed in rows and columns within this function, right? These are just any number that we want. And then here we did R times C. Let's just say with my example, R is, just make it easier for ourselves, R is 2, and then columns is 6. So these two together make 12. So R times C is 12, and 4 times 3 is also 12. So this will be okay for us to continue. If our in our if statement, so if statement is if this it would have been faster if I just wrote it out. Does not equal rows times columns. Rows times columns, which this should be 12 as well, and this is 12 as well. We just return original matrix. So we're just going to return all of this. So that's the end of that. Okay, so then after this, we're going to create our flattened matrix, which is just going to be a vector. So vector flat matrix, and this is of type int. Let me write this out better, sorry. Flat matrix. And then we're going to use 2 for each loops. So for const auto row within the matrix or original matrix. So what this is doing is, if I grab, let me just grab this stuff. write that there. So this means for our current row within matrix, so we're going to start off, we're going to start off at our first row within matrix. So it's going to start off here with row 0 or row 1, and within this for int element within the current row. So then we're going to pass this row into here, into the next, for each loop. So this means within our current row, we're going to count all the elements before moving on to the next next row. And we're going to count and push them into the flattened matrix. So flat matrix dot push, I think it's underlined, back, pass in element. So here we're going to push into flattened matrix. So FM, we're going to push 1, 2, 3 for our first row. So this is what this is going to do for our first row. Then move on to the next one. Pass it in 4, 5, 6 before moving on to the next one. 7, 8, 9. And then lastly, 10, 11, 12. So this is just going to create just one single vector with all the numbers within. So after that, we need to create the flat matrix index, which is going to be the counter essentially for this vector to grab whatever element, to grab the element that we want, to grab all the elements essentially for our new matrix. So f flat matrix index, set this equal to 0. So then we start off at this, because remember this is indexed at 0. This is technically 0, 1, 2, 3, so on and so forth. Sorry, I'm jumping the gun. Didn't mean to delete that. We need to create our new matrix after this. So this would be a vector of vectors of type int, and we're just going to name this nm for new matrix, and this is going to be of size whatever row we passed originally. So in our example, it's going to be 2. So R is going to be, we're going to have 2 rows, and each row is going to have a vector of type int of size C. So of size 6 in this case. So this is going to be 6 elements. So we're going to have 1, 2, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. This is going to be the result of our new matrix, a 2x6 matrix. And then we created the flat matrix index already. Now we just do 2 for loops, a nested for loop. So for int row is equal to 0, while row is less than our current row, the new row that we inputted, plus row. And then for int column is equal to 0, while column is less than C, our new the new amount of columns we put in, so 6. So while this is less than 2 and this is less than 6, sorry, pointing at the wrong thing, 6 plus column. And then here we're going to pass in the new matrix. So new nm at array row, or at index row and index column is equal to flat matrix at array flat matrix index. And then flat matrix index plus plus. So essentially what this is doing now is, in our first loop, since both row and column are 0, so we're at the 0th row, so our first row. So this is our first row, or aka 0, because we're using 0 index. 0 row. For int column is equal to 0, so column is also 0. Plus plus column. Pass in right here 0 0. So at the current row 0, column 0 as well. Pass in flat matrix at flat matrix index, which is also 0 right here. So we would, let me copy this. Copy. To paste it. So here we would come to the 0th element within flat matrix, which would be this one right here. And we would pass that into row, new matrix row 0, column 0, which is just this first, sorry, not 0, 1, which is just the first spot within the new matrix. So then in our next loop, this day 0. In our next loop, this would be 1. Row is still 0, column is now 1, and we already added plus plus matrix, or for the matrix index, so this is also technically 1 as well. This is technically 1. So now we go to the row column 1, which is now the next element, and then what is it? Matrix index is now at 1, which is now this element, and then we would pass this into the first row. And remember, these are already in we already have the space initialized, so 1 2 3 4 5 6, so we already have the empty space initialized for both rows. So once this first row is done, this one's created, so we already have the space initialized. So we just have to fill it up, and so on and so forth. It keeps on incrementing column. This just keeps incrementing because this is the flat matrix index. 2 3 4 5, up until 5, or up until 4. 1 2 3 4 5 6, sorry, up until the index 6. And then this is when we would update row to be 1, and then we would update this, move it down to here, and then just pass in the rest of the elements within flat matrix, and then you have our new matrix right here. So yeah, that's essentially it. Hopefully y'all understood. If there's any questions or comments, let me know.